What's up, guys? I've got a video for you. This one is on the geometric series. This is from the Algebra 2 content. We're talking about polynomial factorization. So first of all, what even is a series and how is it geometric? A series is like a sequence in that there's some sort of formula or structure that outlines a series of terms, a sequence of terms. Series just means that we're going to add them. So like if we start with 64 and then 32 and then 16 and continue following the pattern of cutting in half, then we can write down an infinite number of numbers. So we're going to use S sub n to describe a formula where the sequence is finite. And in this case, it stops after 9. If you think about it carefully, you can write down 64 and then 64 times a half, and then 64 times a half times a half, and then 64 times a half times a half times a half, and that pattern of multiplying by a half actually translates to the use of exponents. So just a little reminder there, we're going to go ahead and find the first 9 terms. So A is going to represent like that first number, that 64, and then R is going to represent that ratio that we're multiplying by. We're multiplying by 1/2. The 9th number translates to multiplying by the ratio 8 times. Now, a trick here with this one to get to a formula is to actually multiply every term by the ratio, by R. That even includes multiplying this S sub n, the answer to the sum of the series, multiplying that by R. So left side, right side. And cleverness, we're going to subtract the two. We're going to subtract the first formula, S sub n, and go ahead and go back and watch how it was constructed, and I'll reconstruct it here. We're going to subtract it by R times S sub n. And this is just one of those, like, if you didn't know, that's okay. But it's a trick that's used, and then now that it's a tool, maybe you can use it as a math tool later on. Turns out, though, by multiplying by R, you've increased all of the exponents of R up by 1, and then as you subtract, all of those middles cancel out. That's the genius of this problem. So we're no longer looking at A times R and A times R squared and A times R to the third. It all canceled out. We're left with the first number and the last number, which, if you know, makes this formula super easy. What is the 9th term? And what was the first term, the A? So finding this formula allows us to just plug in 64 as the first number, the 9th term. We're multiplying by R of 1/2 every time, and a little calculator work, calculator magic, we wind up with an answer. I don't speed it up here. I'll let you go ahead and maybe just scrub through it, but I want to give you a chance to kind of see just there's really at this point just arithmetic happening. Don't forget, when you were dividing by a half, that's the same as multiplying by 2, and the answer for this question is 127.75. There's some other variations here, and so I want to make sure that I share them with you. So I'm not going to do every question from the task, but I'm going to give you a fair amount of them that you can consider. Let's start with that formula. So the formula that we just created says that the sum of the series of n terms is the fraction a times 1 minus r to the n power over 1 minus r. So if you have information, you can plug them in appropriately. Or, and this is going to be helpful with using Desmos, we're going to solve the formula to try to get like the a or whatever term by itself. In this case, most of these are just a or r, or I'm sorry, s sub n. They're not going to ever be r or n. That's a little too complicated at this stage. But the point is you can plug them all in. So we're going to plug in the fact that the first term of the series we need to know, but we know what it all sums up to, and ultimately we get 15,624 times -4. There's a little error here, and you'll see me comment it. That should be a negative 15,624 because it was 1 minus. So make the denominator negative. That makes the 4, the initial value, positive. Next question. Once again, just kind of setting it up. And this one, again, we're going to use Desmos. Here it is. So the formula, S sub n equals a times 1 minus r to the n power over 1 minus r. That is the formula for a geometric series. And it was constructed in this video, and you can use it, but all you really have to do is just plug it in. Hey, this formula can totally be calculated in Desmos. So set your parameters in Desmos. The initial value is 256. The common ratio is 0.5. And then I'm just going to type that formula straight as it existed on the page, and just type in the 6th term. You want to know the sum of 7 series, 8 series, etc. So you can use that formula. You can use Desmos. You can use what we talked about in the first question. Just recognize the pattern, list out your A, R, N, and S sub N, and you've got it. Thank you for watching this video. This video is brought to you by the meme. Okay, Josh, did you forget to upload your final portfolio to Google Classroom? It's the sign of the times. Thanks for doing some math with me. See you in the next video.